Okay, welcome back to GIS 215. We'll be recording a lecture today introducing the Geodatabase. So you may have already started looking at this PowerPoint and this module for this week. I'll try to speak up a little bit so everyone can hear better. This PowerPoint loosely follows some of the information in the Esri online e-learning area, although there's some things in this PowerPoint that aren't part of that course. So let's just jump right in, and we'll have some slides as well as a little bit of demo as well as we go. So this first part is a review. You should remember this from our early discussions of data models and Esri data formats. The Geodatabase is short for Geographic Database. This is the native data format for the ArcGIS desktop platform software, and probably moving forward into ArcGIS Pro and their future products as well. So ArcGIS software is fundamentally based on this data model, and it's a unique data storage format. It's kind of similar to the coverage in that it allows us to store some advanced data types and work with topologically correct features. It also includes functionality of multi-user editing if you purchase one of the higher licenses of ArcGIS Desktop. So remember that over time, spatial data formats have changed over time as technology has changed. A lot of these spatial data formats work with specific software. They all have advantages and disadvantages, and we use them to represent real-world kind of things in a computer. So this is a little bit more detailed look at the Esri spatial data storage structures or their spatial data formats as they grew over time. You can see the coverage was around a long time ago in '83. They also had a triangulated irregular network model, the 10 model from '85. Their first stab at having multi-user editing was using tile-based libraries and something called Librarian. They had different raster data storage options, image catalogs, and grids. ArcStorm was a second look at multi-user editing. Then they came out with the shapefile. And down at the bottom that you can't see there, it says Spatial Database Engine. So these are a little bit more detailed, and the Geodatabase came out down here at the end as well. So we're talking about storing vector and raster data. That's a big advantage to the Geodatabase, is that it allows you to store raster and vector data natively inside of your one central repository, your Geodatabase. So that's a big thing people say about the Geodatabase. They say it's a big advantage is that it's one central repository for all of your GIS data. So this data is stored usually in a relational database management system. It's leverages the functionality and the ability of relational database management systems to efficiently store information in multiple related tables. So the Geodatabase uses a relational database management system or a file system structure in the case of the file geodatabase, which actually acts like a database management system. It's just natively encoded by Esri and does not take advantage of a different database management system like Microsoft Access or SQL Server or Oracle. So you've seen this phrase or sentence before. At the most basic level, a geodatabase is a container for storing spatial and attribute data and the relationships that exist among them. That is a similar definition to what we call a data model, period. And geodatabases are created, edited, and managed using standard menus and tools in ArcCatalog, ArcMap, and ArcToolbox. So this work is done just right natively inside of ArcCatalog and ArcMap. There's no programming or anything. The tools are there to create and manage and edit geodatabases. So again, it's based on relational database concepts. It's a set of related tables. It's managed through something called structured query language, It's a standard database language used to interact with database management systems. It leverages the strengths of the underlying database management system. So it uses database management system concepts and functionality to manage spatial data. Database management systems have been around for a long time. They have always allowed you to store things like text and numbers and dates. What they didn't allow you to do was to store geographic information, a spatial data type. And so the geodatabase leveraged the earlier database management system and then allowed it to store and manage spatial data. So nowadays, a lot of database management systems, like the higher end, more expensive, more robust database management systems like SQL Server and Oracle, allow you to manage spatial data types just like it allows you to manage other data types, such as text, numbers, and dates, things like that. The geodatabase is referred to as an object relational model because it employs a multi-tier architecture where the geodatabase objects and its behavior and the database management system and behavior are supplied through the geodatabase application logic. So the database, essentially the database handles the objects and some behavior, whereas the geodatabase specific things are handled through the application logic, which would be ArcGIS Desktop. So essentially it separates your database management system and the things it does and the application logic from the GIS software. So the GIS kind of things are done in one place and the DBMS stuff is done in another place, and it allows you to leverage different database management systems because of this separation and multi-tier architecture. Here's a lot of advantages of using a geodatabase, and you see a few in the virtual the Esri training site, but here are many others. The central repository is the first thing everyone always says. If we go around to the right, I'll hit on some of these, not all of them. The geodatabase has some advanced functionality that allows you to manage data integrity through things like drop-down list, which is one type of domain. A coded value domain is simply a drop-down list in an attribute table so that you can ensure people enter in one of a list of attributes rather than putting in an incorrect attribute. Subtypes allow you lightweight classifications of your features within a feature class. You can have advanced geometry types in addition to points, lines, and polygons. You can have geometric networks and topologies and other things. You can scale geodatabases from a small single-user geodatabase to a very large multi-user geodatabase depending on your needs of your organization. You can have multiple people edit your geodatabase if you set up the appropriate type of geodatabase. You can model and design your databases using unified modeling language tools, as well as advanced functionality of linking attributes tables to annotation in a map, so that if you change an attribute table, the annotation changes in the map. Rule-based topology and continuous sets of features. All of these are advantages of a geodatabase. Some we hit on and some we didn't. Some of the advantages and benefits you see here require higher license levels, and you really have to have the need for them to invest the time and the extra layer of complexity and money to implement some of these things. So at the simplest level, with a basic license of ArcGIS, just being able to store all of your data in one central repository, manage things like domains, as well as having attribute fields like the shape area and the shape length field that automatically update are big advantages of using the geodatabase. And if you work in ArcGIS desktop with ArcMap and ArcCatalog, if that is the primary environment, your GIS environment you're working in, the geodatabase is really a great choice of a data model to work with. So there's different types of geodatabases: the personal, the file, and the enterprise, or actually this slide should be updated to be called a multi-user geodatabase. That's where it's updated in all the other slides. So personal, file-based, and multi-user. The bottom slide is the highest level geodatabase, and the multi-user geodatabases actually have three different types of geodatabases. They have the desktop, the work group, and the enterprise. So there used to only be one type of enterprise geodatabase, and we called them SDE geodatabases because they're built using the Spatial Database Engine, which is an Esri middleware to allow you to manage your GIS data in a third-party relational database management system. So when there was just one, we just called them enterprise or SDE geodatabases. Now you'll see them referred to as multi-user geodatabases. So we'll talk about each of these three. Again, when the geodatabase first came out, there were only two. So there was the personal geodatabase, the top one, and there was the enterprise geodatabase. Now there is the personal, the file-based, and the multi-user, and the multi-user has three different types of geodatabases. So multi-user here, enterprise of which is one of those types. So let's just jump right in. The personal geodatabase was the first geodatabase created at the original version of ArcGIS Desktop, and it was stored in Microsoft Access. You did not have to have Microsoft Access to create one. It used the Microsoft Access Jet engine to create an Access database, and that Access database was used to store your spatial data through some application and program logic provided by ArcGIS. It could be read by multiple people at the same time, but it can only be edited by one person. One of the big limitations to this geodatabase was that it had a maximum size of 2 gigabytes. That, and it could only store vector-based data. So using the Microsoft Access database caused some limitations. This geodatabase was suited for smaller work groups, and if you only had some small to moderately sized data sets to work with. Pretty quickly you can get over 2 gigabytes in size, and so this geodatabase is not recommended to be used anymore. You will still see it, you can still create them, but the file geodatabase is recommended to be used instead of these. So Microsoft Access is a good database management system, but it's not extremely robust, and it does not scale to large sizes. As Microsoft Access databases get larger, they do not perform as well. So the file geodatabase, it's similar to the personal geodatabase in that you can only have a single editor unless you're editing different feature classes within a database. The way the file geodatabase works is it stores GIS datasets in a file system folder, and you can use and create these with any level of ArcGIS, any license level. A big advantage to the file geodatabase is there is no limit on the geodatabase size. Inside of a file geodatabase, there is within a feature class. A feature class can store up to 1 terabyte in size, but it can be extended to 256 terabytes. So where a geodatabase doesn't have a size limit, the feature classes in it technically do, but you would typically not need as much space as is available. Vector data can also be compressed into a read-only format in a file geodatabase, and long transactions and versioning are not supported, and that's a reference to the fact that multi-user editing is not supported. Long transactions and versioning have to be supported by the database to do multi-user editing. So file geodatabases. File geodatabases are the most common geodatabase you'll see now. They can be created, as mentioned, at any license level. So if you have a basic license level of ArcGIS, you can create a file geodatabase. You can also create a personal geodatabase, even though that's not recommended anymore. So a single person creating and managing a geodatabase for themselves would probably create a file geodatabase. The next level of geodatabases are the multi-user geodatabases. Of these, there are 3, and these add a layer of complexity and investment to be used. To be sure, there are people who need this technology and can afford it, and it makes their business run much better. So multi-user geodatabases leverage the ArcSDE technology, the spatial database engine. It is implemented on a relational database management system platform to provide organizations with a central scalable data storage and management system. Utilize some functionality that's not available in single user geodatabases. It allows you to provide a better level of security because you can set up different users to have different permissions to edit different feature classes within a geodatabase. For instance, maybe the tax parcel layer can only be edited by someone in the tax assessor's office, but then your planning layer is editable by 2 or 3 people in the planning department, whereas your roads layer can be viewed by all those people, but someone in the public works department is editing and maintaining that one. So you have all these different data sets in a database at an organization like a county where you have different users needing to edit different things and being in charge of different things. So with a multi-user geodatabase, you can set it up so some people can read all the data sets from the database, and then different individuals can edit the different layers they need to. There's also different data integrity and features like backup and recovery, rollover and failover that are better used for a large organization where a live database of information is integral to their work every day. So of these multi-user geodatabases, as I mentioned, there's the enterprise, workgroup, and desktop geodatabase. While we're talking, I'm gonna go change this slide from the very beginning, and I should have just done that while we were working through this. I should have just done this since I'm working on this live file, multi-user geodatabase. All right, and we'll just keep moving on. Okay, so of the multi-user geodatabase, you can't create these without having an advanced license level of ArcGIS, and it's the kind of thing that is it's a higher level kind of thing. And for a class like this, you need to be familiar with these and know if you end up working at a place like a county, you may interact with these kind of databases, but they will have already been set up by someone, and you will just be added to the database as a user. You'll be able to connect to the database, access the information in the database that you've been given permission to access, and work with it as you've been given permissions. So let's talk about each one of these. These allow you to kind of learn about them and grow from a small multi-user geodatabase to a large multi-user geodatabase. The lowest level of one of these is called a desktop multi-user geodatabase, and each one of these multi-user geodatabases needs to use a database management system where the data resides. With the first two, the desktop and the workgroup geodatabase, they utilize a database by Microsoft called SQL Server Express. SQL Server is a database management system by Microsoft, and they give out a free version called SQL Server Express. So with a advanced or a standard, the two higher level versions of ArcGIS, licenses of ArcGIS, you can create these. They are limited to 10 gigabytes in size, and they support 4 simultaneous connections, 1 editor and 3 readers. And so the thing about SQL Server Express is that it's free. You don't have to purchase the third-party database management system that you use. They are built and created and managed using standard tools in Arc Catalog and Arc Toolbox. So when you start working with these database management systems that are supported by the multi-user geodatabase like SQL Server, Oracle, and Postgres, just to mention 3, they are an entire software to manage in and of themselves. The database management system has a management tool to work with, and typically a county or a city has a database administrator, a DBA, that manages these kind of databases. So what the desktop geodatabase level of the multi-user geodatabase gives you is the ability to work with one of these databases like SQL Server Express without working with its management tool. You manage and build your databases using Arc Catalog and Arc Toolbox. The workgroup geodatabase, you have to have a higher license level. It's licensed through ArcGIS Server, so you're not in the ArcGIS desktop licensing world anymore. So if you need to support 10 simultaneous users and editors, if you have a database that needs that much editing and management day to day, that you need 10 people to be able to get in there and manage it and update it, then this is a good option. This is also set up and managed and worked with through Arc Catalog, but you need a higher license level to work with it. It is limited to 10 gigabytes, and it also uses SQL Server Express, so you don't have to license and purchase a database management system. The final multi-user geodatabase is the Enterprise Geodatabase, and it is included with ArcGIS Server. It provides unlimited number of users and size to your database. The thing about this one is you have to license a database management system like SQL Server or Oracle in addition to licensing this product. There is a open source option for your database management system called Postgres, and many people choose to use that. The big thing about these is the database can be scaled to any size and any number of users. And so a large organization like the county that manages a lot of data for a lot of people and a lot of uses use this option. It is it does have the highest level of complexity and it's an advanced topic. You can see a summary of the multi-user geodatabases here. Please check that out as required reading for this week. Okay, so back to what a geodatabase is. We've said it's a place to store your attributes and your spatial data and your relationships between them. So it's a database of geographic objects, and objects have properties and objects have behaviors. So the properties are stored in the database. They're the things like feature geometry, whether it's a point, line, or a polygon, and different attribute fields. Things like rules, relationships, classifications, and metadata. They are all properties of the geographic objects that are stored in the database. Then you have behaviors that can be performed on the objects, or the objects have behaviors, and they're implemented by the client. So the client, in our case, is the ArcGIS desktop software, and it operates on the properties. Things like geodatabase integrity, the domains and the subtypes and the topological rules that define how things are connected and check the topology and networks of features are all enforced by the clients, by the GIS software. The basics of a geodatabase is that you have tables, non-spatial tables, feature classes, and feature data sets. Non-spatial tables are often referred to as object classes. There are collections of rows and columns They look like this icon, just a table looking icon. Feature classes are a collection of features, point signs, and polygons. Conceptually, a feature class is a lot like a shapefile, except for you can have many feature classes within one geodatabase. A feature dataset provides a way to organize a collection of feature classes. So with a feature dataset, you put multiple feature classes inside of it. So conceptually, it's kind of like a coverage, where a coverage had multiple feature classes. However, the difference is, in a coverage, all feature classes were topologically related, whereas in a feature dataset, they may or may not be topologically related. That if you do have topologically related features in different feature classes, you must manage them in a feature dataset to model and manage that topological those topological associations. You can also keep up with rules, attributes, subtypes, and domains, and relationships. So we'll look at some of these in this class. We won't quite get into everything, but we'll look at a lot of these things. So feature classes, and this is somewhat of a review, so we should really be getting the hang of this thing now. Feature classes are collections of features that have the same geometry, attribute fields, spatial reference, and behavior if there is behavior. So conceptually, it's like a shapefile, except for they do more. They can have more behaviors built into them and keep up with things like length and area and perimeter. So a feature class is a layer of GIS information. We don't mix points and lines in a feature class. They're either points or lines or polygons. They've got a common set of attributes like a name, and they have a spatial reference. So the types of feature classes, points, lines, polygons, and annotations are the most common, but you'll also see some advanced things like dimensions, multi-points, and multi-patches. Points, lines, and polygons can be single part or multi-part. An example of a multi-part polygon might be Hawaii, where you have many separate polygons that make up the state of Hawaii. There are many polygons, but they are one state. So you can have single or multi-part lines and polygons. Your feature geometry are stored with coordinates. We typically think of X and Y right off the bat, how we manage a point in a Cartesian coordinate system. Locations of points are defined by an X and a Y coordinate. They can also have a Z, which gives them elevation. And they can measure measurements with an M value. These are used in dynamic segmentation, linear referencing, and things like routing, where you have measurement values between locations on a line. Lines can also be stored as straight segments, circular arcs, elliptical arcs, and parametric Bezier curves. So we have lots of different ways we can store our geometries and coordinates. This shows our feature coordinates with an X, Y, and a Z, as well as an M mentioned in the last slide. Some more examples of straight lines and curves and the different kinds of parametric curves we can make, how Z values are stored, and measurements. So let's discuss the feature dataset more in depth here. A feature dataset is a container for feature classes. The feature classes that reside in a feature dataset must have the same spatial reference. That means the projection, coordinate system, units, everything. Feature datasets are used to either spatially or thematically integrate related feature classes. Okay, so what does that mean, spatially or thematically? If you want to manage spatial relationships between two feature classes using a topology like this topology in this feature data set, your feature classes must reside in a feature data set. So anytime you work with a map topology, or not a geodatabase topology, or a geometric network, your feature classes that are spatially related connect in some way, have connecting lines or polygons or coincident polygons. They must be managed in a feature data set. So at the original release of the geodatabase, that was the reason for using a feature data set, was to spatially integrate related feature classes. Since then, we've started using feature data sets to sometimes just thematically organize things. So when you use a feature data set to thematically organize some feature classes, that's doing it by, just as an organization technique, almost like you use a folder on your computer to store files. So inside of your geodatabase, you might have a folder called, I often do it by where I get my data. So I'll have a folder called Buncombe County, or a featured data set called Buncombe County, and all my Buncombe County feature classes will go into that feature data set. So the primary purpose of feature data sets were to organize related feature classes for building topologies, network data sets, terrain data sets, or geometric networks. That primary purpose is the spatially integrated thing. A secondary purpose, and often more used, is thematically organizing your data in a database using feature data sets. An important note is that all of these primary purposes, the spatially integrating your feature data sets, require a higher license level of ArcGIS. You cannot do those with a basic license level. So many people that use a basic license level of ArcGIS will just thematically organize their feature classes in feature data sets. Raster data can also be stored directly in the geodatabase as raster data sets. Raster data may consist of thematic data, like discrete information representing land use or forest types. Thought I'd give you a little example of that. This is a land use example from Landsat. This is raster data where these are mangroves, and the pink is slash and burn for farming and urban areas growing into the mangroves. So that's thematic land use type. Continuous data, such as elevation or temperature, can be stored in a raster data set, and we can look at that too. Let's come over here to Arc Catalog and check that out. Arc Catalog I'm looking at here, and I'm going to just go to one of my folder connections for my GIS data. And in my GIS data folder here, the X drive is a server. I've got some DEMs. Digital elevation models represent elevation, so we could look at one of these. This shows us some continuous information in a raster format, showing elevation. That could be turned into a shaded relief model, often referred to as a hill shade. And you can see different examples of this kind of data. All right, so I wanted to make a mention of Arc Catalog and Arc Map here while I'm here. In the Esri e-learning site, and a lot of their courses now, they utilize the catalog window that is embedded within Arc Map. There used not to be a catalog window embedded in Arc Map. You had to use the separate standalone Arc Catalog, and I still use it a lot because of your ability to preview data. That preview tab there is a reason to use Arc Catalog standalone. In Arc Map, it's harder to preview layers, and so if you're using the catalog window within Arc Map, see here's my WNC DEMs, I can get to them, and it's a really great tool inside of Arc Map to grab and drag layers over to Arc Map and to manage your geodatabases. However, if you need to preview your data, I like using Arc Catalog. All right, back to the PowerPoint. This is worth looking at, the Esri ArcGIS desktop functionality by license in the Geodatabase. So the different license levels of ArcGIS desktop, when you license this product, you license a basic, a standard, or an advanced license, and the functionality is tiered across the software for the Geodatabase, as well as tools in Arc Toolbox and many different things you can do. So extending feature classes. What else can you do with feature classes? This is a list of a lot of things, and we're going to cover some of these, certainly not all. We'll see feature data sets, subtypes, attribute domains. We'll talk about relationship classes. We'll create topologies. We won't do network data sets or geometric networks. We'll probably see it. We probably see an address locator and some other things. So, how about building a geodatabase? To build a geodatabase, you should first evaluate existing data. You should look to see if the existing CAD data, DBase files, coverages, shape files, text files. You should define your database structure. When you define your database structure, you essentially design your database. You come up with a blueprint of all the data, the geometry types, the attributes, and the spatial references that will be stored. From there, you create your geodatabase, and finally, you add your data. So I wanted to look at a couple of geodatabases. I won't take a lot of time, but I wanted to kind of look around at some geodatabases and talk about their data types and some of the things with them that are worth considering. So a disadvantage of using this standalone Arc catalog window is that if you have data loaded in ArcMap and you want to update the database by managing the schema or doing much, you'll see a lock come on that says you can't do that because it's locked in another program. If you use Arc Catalog embedded in ArcMap, it works a little bit better as far as the different applications not locking each other from doing different things. So I wanted to take a minute here just to look at and explore some geodatabases. So I've got some data from the Metropolitan Sewer District I thought I'd look at here. Here's the MSD database. It's got a .gdb extension that tells you it is a file geodatabase, and if I open it up, you'll see it's got feature data sets in it, as well as a standalone feature class outside of a feature data set, and a table of some information, tabular information not tied to a point line or a polygon. And let's look at maybe our MSD sewer edits feature data set. So they've got a feature data set where they do some edits, it looks like, and inside of this one they have a network data set. And network data sets will combine points and lines into a single network data set. You'll also see things like topologies. That's a topology. Again, to build a network data set or a topology, these have to be in a feature data set, and they require a higher license level of software. So those are a couple examples of feature data sets. I'm connected to all kinds of folders here. Documents, downloads, Dropbox. I'm going to look in my GIS 215 folder, and I wanted to just do a little bit of an example where I create a geodatabase from scratch. And let's look at what files and folders are created and think about what happens here. So if I make a new file geodatabase, it comes in with the name, new file geodatabase, Since it's highlighted like that, that means it's in edit mode and it can be renamed. So I'm going to just call this one class demo. There's my class demo file geodatabase. And let me zoom in for you so you can see it there. And now, if you look with me in Windows Explorer here, and I look in that folder, and instead of navigating all of that way to that folder, I'm just going to copy that address there. It's on my U drive. Go Alt-Tab back over here and paste into there and press Enter. That'll take me right to that folder. You'll see that what got created here is a folder. When I created my new file geodatabase here, in Windows Explorer, it created a folder, and there's a whole bunch of stuff in this folder. As I do things in Arc Catalog, these files in this folder update and things happen. There is no reason for you to ever come in here and touch one of these files. You also don't ever want to save anything else to this folder. When you save a map document, since file geodatabases are a bunch of binary files organized into a folder using Arc Catalog and Arc Map, you could save other files to this folder. Don't do that. When you do things in Arc Catalog and Arc Map, like when I come in here and I create a new feature class, look at the time here, 9:52. If I create a new feature class and I call it sewer lines, and I'm going to make it a line feature class, go to next. I'll give it the same spatial reference that some of my other GIS data has. I'm going to give it State Plane, North Carolina, US feet. Okay, so as I do things here, look at the time now, it's 9:53. I'm just going to, okay, so the sewer line, I'm going to give it a type and a diameter. So I'm giving it some fields here. A type and a diameter. Diameter should probably be a float. So short and long integers allow you to store whole numbers, no decimal places. A short integer allows you to hold up to 32,000 plus, or sorry, 32,000 or just less. I don't know the exact numbers in the 32,000 range. Long integer is over 32,000. So if you have numbers higher than 32,000, store a long integer. Float and double are similar. Float allows you to store less significant digits than double. You can store text, dates, binary large objects, rasters. So diameter of pipes are small numbers. They do have decimal places though, like 1.5 inches. So let's use a float. So I'm going to finish this. It's now 9:54. I have a sewer lines feature class, and when I created that feature class in Arc Catalog here, inside of my geodatabase folder, all of these binary files, if I look at the date modified, you can see a bunch of stuff was updated at 9:54 when I finished creating that thing. So as you do things to your database, like create new feature classes, edit features, update spatial references, these files in here are updating. You don't ever need to get in here and mess around. If you were to, by accident, delete one of these files, you would probably never open the geodatabase again that you were working on. You would mess up all of your work. So a neat thing about the geodatabase, and I'm just going to load this sewer lines layer on top of this map here. The neat thing about the sewer lines, about the geodatabase, if I preview this geodatabase, there's nothing there, or this feature class. If I look at the table, you're going to see the fields that I included, the type and the diameter, but there's also a shape length field. It stores the length of the line in coordinate system units, which are feet. So if I were to start editing, let's see if I can zoom and do this. If I were to start editing, and I start editing my sewer lines, And now, that's okay, don't worry about that spatial reference. I can pick my sewer line here, and I'm going to draw a line in, and I know this is not in where a sewer line is. Double click it, there's my line. Now, if I open the attribute table, you'll see there's a length on that line. Okay? And what happens if I split that line? I'm going to split it right there. Look at what happens. They update. Select that line, I'll split it again. You'll see that shape length update. That's the only field that ever updates. I could add a miles field, and that miles field I could populate, but it would not automatically update. So that's just a little bit on the Geodatabase. I'm going to let you jump into your Esri training site and do the work for this week, and you can come to me with any questions you have.